Hey math kids, we're going to talk more about the sine and cosine functions that we talked about on the previous video. And I'm going to write a couple relationships down first. So if we have sine x, this relates to cosine in this specific way. So we talked about this on the last video a little bit. This is a little more specific. And then cosine relates to sine in this specific way. So we see no matter what, which one we're looking at, we're just 90 degrees or pi halves away from becoming the other one. Okay. So in the case of cosine, we use negative pi halves, and in sine we have positive pi halves. And remember that this is counterintuitive, so this is actually a shift. This one is a shift left, where this one is a shift to the right. Okay, because when we're inside of a function, it works counterintuitively. Okay, let's talk a little bit about this. This is a diagram in your book, but maybe I'll explain it just a little bit before we start with some examples. Okay, so if we have a sine function, this a right here, so if there's a number out in front, it's called the amplitude. And specifically, that's going to make it get taller. It gets further away from the middle. And so if I have like a sine function that looks like this, and then I put a 2 out in front of it, it's now going to look like this. So the valleys and the peaks both increase by 2, or whatever value that we plug in there. Okay, let's talk about this D. That's just going to be a vertical shift. Okay, your book calls it a vertical translation, same idea. So if this was our original, and then we shifted it, or added 2 to it, it's going to stay the same size, but it's just going to shift up 2, like that. It's just going to move up. Okay, the C is a horizontal shift. I'm trying to fit an I in there, but whatever. So horizontal shift, and does the same thing. If this is our beginning, it just shifts to the left 2, shifts to the right 2, or whatever. Okay. Once again, though, it will act counterintuitively. So if it's a negative number, it actually goes to the right. If it's a positive number, it goes to the left. Okay, just like up here. Okay, and then finally, that B out in front right here, it affects the period. So it's either going to repeat sooner, like more often than 2 pi, or less often, depending on how that works. And we'll talk more specifically how that in the context of an example. Okay, that's just a general overview. Now let's try one of these. So we have y equals sine x minus pi thirds. Okay, and they want us to sketch the graph just in between 0 and 2 pi. So one period, well, one original period. Okay, so what I'm going to do is I'm just going to graph regular sine. I'm not going to worry about the other stuff that's going on. And I'm going to mark some of my important places. For this class, all this stuff I'm writing in blue, this is what I expect you to mark each time. Okay, you don't need to mark every single spot. Now, if it's minus pi thirds, it's going to move to the right by pi thirds. So in other words, we need to add pi thirds to each of these answers. And so, in a general sense, it's going to look like this. But if we wanted to know this like actual value here, and actual value here, and actual value here, we know this one's going to be pi thirds, because it's just going to be 0 plus pi thirds. But we would have to say pi plus pi thirds. Think of the pi as 3 pi over 3. And then that would end up being 4 pi thirds. Then we'd have to do the same thing here. 2 pi plus pi thirds. Think of the 2 like 6 over 3. And then 6 plus 1 gives us 7 pi thirds. Okay? Notice that the amplitude doesn't change. It still goes to 1 and negative 1, even though my drawing's a little bad. But that's what it should look like. Okay, let's try another one. So this time we have y equals cosine of 3x. And so once again, I'm going to start by just drawing regular cosine. So it goes from 1, negative 1, this is pi, and this is 2 pi. Once again, that's all the stuff I expect you to draw. You don't have to draw stuff in between there. Now, the 3 is going to make it, we need to draw like 3 cosines within that same period. And in your book, they give us, they say 2 pi over b equals the new period. And so we're just going to take 2 pi, which is the original period, and divide it by b, or in this case 3. So it's going to be 2 pi thirds is the period. Now we need to know where 2 pi thirds is, and 2 pi thirds, so this one would be pi halves, and this would be 3 pi halves. And so what we want to do is figure out where this needs to be on, like where one period needs to go. And so it's going to be roughly right here. A quick way we could do it with a calculator, or just like estimate, this is like 3 halves, so this is roughly like 1.5. This is, pi is roughly 3. And then if we do this, like 3 divided by 3 would cancel, so it's roughly 2. So it's going to be somewhere in between there. Okay? And so what we do is we just draw a cosine that goes that far, and then we draw one that goes, roughly the same thing, and then roughly the same thing. So notice that I have 3 full periods from 0 to 2 pi, because this made it 3 times, made the frequency 3 times higher. Okay. All right, let's do another one. So this time we have cosine x plus pi sixth plus 1. Once again, I'm going to draw my original, just regular cosine. 1, negative 1, pi, 2 pi. And this has 2 translations in it. So we're going to move left by pi 6. So this goes left. And so, oops, I can draw it like that. So kind of think of it just moving left. So we just want to follow this curve, but kind of like behind it. I always have the hardest time drawing this. So if we take this point, move it here, 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 this point, move it here. Okay, there we go. I always have like a hard time drawing these. And that wasn't right. Okay. And then it would start to go down. And this would continue to go up. Okay, something like that. So just imagine it shifted to the left by pi sixth. And we're not going to be super exact with this. And then the next thing is we want to shift it up by 1. So now I'm going to take the green, shift it up by 1 all the way up here, and then I'm just going to draw function, but shifted up by 1, and so this point would be at 2. All right, that's pretty bad drawing. But we needed to shift to the left pi 6 and up by 1. And then we have just one more. We have negative sine x. So I'm going to start with just my regular sine. And then the negative out in front is just going to take all of the y values and make them negative, or if they're already negative, make them positive. So for example, this point is going to shift down here, and this point is going to shift up here. So it's going to be just like the opposite, like that. Okay? We have a couple more to go through. So we have y equals 3 cosine 2x, and they just want us to sketch the graph. So once again, start with a regular cosine. We're just going to assume that this is 2 pi. This is pi, 1, negative 1. Okay, so I'm going to first take into account the 3. The 3 is going to make this 3 times taller. And so we go to 2, we go to 3, we go to negative 2, go to negative 3. And so we just draw like the same cosine function. The 0 is going to be in the same place. It's going to look like that. Okay. So that's just taking into account the 3. Now the 2 means we need to draw 2 of those in that amount of time. So we need to draw this, the same height, but we want it to end at pi half, or at pi, and then we'll draw it again for that. So I'm going to start here. I'm going to go down, up. So there's 1 period, but we need 2 periods within the same distance as 1. So notice how I have 2 periods of my new cosine function because of the 2. Okay? All right, let's keep moving on. So the yellow, technically the yellow is the final answer to the whole problem on that one. And okay, it says find the unknowns in this function. Okay, so we have this, goes like this, goes like this, kind of like that. Okay, so they tell us at this point, and this is like a sine wave. I know it looks a little like choppy, but that's just my bad drawing. Okay, so we have that, and then we're told that basically what this is telling us is that we've changed the amplitude and we've moved it up or down. And then we're told that this point is 7 pi 6 1/2. Okay. So what we're going to do is we're going to use this piece of information to find some stuff out. So we're going to say f of pi halves equals 8. And so if we say a sine of pi halves plus d equals 8. And sine of pi halves, if we use our unit circle or even just a calculator, is just 1. And so that simplifies to a plus d equals 8. Okay, so we have that. Now we're going to use the other point, do the same thing. So we're basically just going to say a sine of 7 pi 6 plus d equals 1/2. And if we use the unit circle or a calculator, we see that that goes to negative 1/2. So it's negative 1/2 a plus d equals 1/2. And now we can use something like elimination to figure this next part out. So I'll just write those. I'm going to just write this one. Actually, I'm going to clear the fraction on this first. So 2, 2, 2 cancels. So we have negative a plus d plus 2d. And then those cancel. So that equals 1. So I'm going to just write that right here. Okay, if we just add these, they happen to line up already. Those cancel. We get 3d equals 9. Divide by 3, d equals 3. And then if we plug that into this one, we get a plus 3 equals 8. Subtract 3, and then a equals 5. Okay, and those were the two pieces of missing information that they asked for. So we know that there's an amplitude stretch based on our answer for A, which was 5, and then we know there's a vertical shift of 3. Okay. And then the last one is find the equation of this sine function. So it crosses here, 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 and they tell us this is pi, tell us this is 1, tell us this is 2, tell us this is 2 pi. And so we know the amplitude is 1, because if we drew the line right here, the distance from here to here is 1. So we know our A is 1. Okay, the period, one repetition, is just pi. And so if we have our 2 pi over b, that equals pi. And so we could solve for b in that case, which if we just did 2, b equals 2. You can just go through the algebra on that. Okay, it doesn't shift left to right at all, and so our c is just equal to 0. And then our d, we've shifted up by 1 because our middle value is now at 1 instead of 0. And so if we just fill out that equation from the beginning of this video, we end up with y equals 1 sine of 2x plus 1. And then we don't really need that 1. So if we just put a y right here and put this around it, that would be our thing. If you need additional help, come to Math Lab. Until then, calculate.